Okay, so I'm gonna write down some properties that we learned about last year with negative square roots. So I'm sorry, negative exponents. So remembering that a negative exponent doesn't make a number negative. We should all know that. And really, what it does, it reciprocates the number. Sounds kind of funny, right? Reciprocates the number. We all know what a reciprocal is, right? Wherever the number is, you flip it to the other location, either numerator or denominator. And that's what it does. So there's three basic properties that we're just going to write down. Okay? The first one is this, and it's the most basic one. If you have some number raised to a negative exponent, say a to the negative n, if we want to express that without that negative exponent, it would be 1. We reciprocate it basically. 1 over a to the n, no longer negative. You guys remember that? We have other versions of this, so we'll just write them down. Say we have 1 over a to the n. This is really just the reverse of this. Okay? 1 over a to the n equals a to the negative n, in case we want to go in reverse. And finally, 1 over a to the negative n, meaning the negative exponent is in the denominator. We reciprocate it, so how would it be without that negative exponent? A to the n. Okay? So these are the three basic properties. If you can keep those in mind, and everything else we did yesterday, because all other properties of exponents apply. So again, if we're multiplying powers, we would add the exponents. If we're taking a power, raising it to a power, we would divide the exponents. If we have multiple factors raised to a power, we would distribute that exponent. If we divide powers with the same base, we would subtract the exponents. All of those things still apply. Okay? But sometimes we want to express all answers with positive exponents. So that's what we're going to want here. We're going to express all answers with positive exponents. Okay? So if you're ready, let's begin. So we'll just do several examples here. Let's say I have negative 3 x to the negative 2. We have two factors here, negative 3 and x. But one of them has a negative exponent, the x. So again, I want to express everything with positive exponents. So negative 3, right? It's fine. What's the exponent just on 3? The number 3 by itself. 1. It's negative 3 to the 1. That's positive. So leave it. X, though, is to the negative 2. So we're going to use this rule. It's going to go from the numerator where it's at to the denominator. Okay, so let's write that. It's going to go downtown. And it's going to become x to the second, no longer x negative. And how about our negative 3? Where does it go? Numerator. It stays in the numerator. Again, It had a positive exponent, so it stayed upstairs. So all we're doing is if you see a negative exponent and it's in the numerator, you bring it down. If you see a negative exponent and it's in the denominator, you bring it up. Okay, if you can keep that in mind, this is easy stuff. Okay, now this next one requires two rules. So see if you can catch it. This one's a little more challenging, just a little bit. Number 2. Negative 4 x, and then let's say negative 2 here. Okay, we've got two rules we need to do for this one. Let's see. Well, first of all, we see a negative exponent, right? We either deal with it first or second, because there's another rule that we also have to follow from yesterday. What other thing would we have to do? Yeah, power of a power kind of rule. We have to share that negative 2 to the negative 4 and the 2. Or we can use the fact that it's a negative exponent, and where would it go? Denominator. Eventually stuff has to go to the denominator, and eventually we have to distribute that too. Which order we do that really doesn't matter. What would you rather do first? Bring it to the denominator first or distribute the 2 first? Okay, let's distribute that 2. Just remember, eventually things move. Okay, so now we share that negative 2. So it's negative 4 to the negative 2, x to the negative 2. Okay, so now we got to do a little more simplifying. First of all, let's think about this. It's negative 4 to the 2. We'll deal with the negative second. How many negative 4s are we going to multiply? 2. And where are they going to go because it's a negative exponent? Denominator. So I got to multiply 4 times 4, or negative 4 times negative 4. 16, but it's positive because there's an even number, right? Okay, and we brought it to the denominator because of the negative. Now we have x to the negative 2. Well, it's going to become x to the negative 2, but we don't want a negative exponent, so where does it go? Denominator. It's in the top right now, but we're going to have to bring it down. So what do we have in the numerator? 1. Any questions on what we did there? We distributed, because that's part of that rule. We have to share the outside exponent. Then we dealt with each one, kind of evaluated each one. Negative 4 times negative 4, it's 16. But it's a negative exponent, so it goes to the denominator. X to the negative 2, it has to go to the denominator, so it becomes a positive exponent. Any questions? Okay. All right. Let's move on. So a lot of these are going to be combining rules from that we discussed yesterday with the rules for negative exponents. Okay, number 3. Número 3. X to the 6th times x to the negative 3. Okay? So we're going to multiply 2 powers with the same base. So first we got to do that rule. We should really do that rule first. What do you do when you multiply powers with the same base? You add them, yeah. I'm going to show that rule because I don't want to lose anyone. So this becomes x to the 6 plus negative 3. And we all know that 6 plus negative 3 becomes 3. So we get x to the 3rd. Do I need to bring that to the denominator? No. It's positive. It's happy where it's at. Okay? Let's try another one. Number 4 x to the negative 11 times x to the 7th. Okay, let's simplify that. What are we going to get when we apply our first rule? X to the, yeah, you got to remember that you have to add the negative 11 plus 7 using that rule. So it's x to the negative 4. Yeah, but it is a negative 4, so bring it to the denominator. I should be kind of boxing my final answers. Let me go back and do that. So we know what's what. That's our answer, obviously. That's our answer. Here is our answer. And this is our answer. Okay. Any questions so far? So just keep the rules in your head kind of organized, and you should be okay. All right, number 5. X to the negative 2 to the 4th. Raising a power to a power. We got to apply that rule first, the power of a power rule. Then we'll deal with the negative exponent if we have one. So what do we do when we take a power, raise it to another power? What do we do with those, the negative 2 and the 4? Huh? Multiply those. I don't want to lose anyone, so I'm going to just show that rule. X to the negative 2 times 4. So that gives us x to the negative 8. But it is a negative 8, so yeah. Final answer is 1 over x to the 8th. Okay. And number 6. Let's do x to the negative 6 raised to the negative 4. What's that going to give us? Yeah, negative 6 times negative 4 is 24. And do we need to move that? Nope. Perfectly happy there. So that's just x to the 24th. All right. I have a few more. Okay, you guys ready? Let's do number 7. We're going to do x squared y, and we're going to negative cube that. Okay, you guys ready? Well, we have to distribute that negative 3. We've already done one kind of like that. So let's do this. Let's share that negative 3. So that's going to be x squared to the negative 3rd, and then y to the negative 3rd. So let's see what that gives us. That's going to give us x to the I put the parentheses around the wrong spot. Oh well. Sorry about that. Okay, but neither of those are happy where they're at, right? So there you go. The next few are going to take a few more steps like this, so we'll just do one in each time. Okay. So on to number 8. Okay. Let's do 2 x to the negative 1 y squared to the negative 5th power. So it's 2x to the negative 1 y squared, all that raised to the negative 5 power. So first thing, it's kind of like order of operations. Get rid of those parentheses. We're going to negative 5 power every one of these. So 2 to the negative 5, x to the negative 1 to the negative 5, y squared to the negative 5. Every one. Then we'll simplify that step. So this is going to be, well, 2 to the negative 5. So how much is that? What's 2 times 2 times 2 times 2 times 2? If you multiply 5 twos. 32. But it'll be 1 over 32 technically. Okay. Well, just keep that in mind. We got stuff in the denominator. So this is, for the time being, I'm just going to write this as 2 to the negative 5. But really, this is 1 over 32. Right? Because 2 to the 5 is 32, but negative would make it 1 over 32. And then we've got x to the, what do we do with these two powers, or these two exponents? Multiply, so that would be negative times negative. It makes it positive. And then y to the, Any questions? Okay, so now we flip anything that needs to go to the denominator or numerator, we do that. So here we go. Well, for sure, 2 to the negative 5, it becomes 1 over 32. Okay. How about x to the 5? In the numerator. That one's happy here. How about y to the negative 10? Yeah. Okay. Any questions? Especially how 2 to the negative 5 became 1 over 32, or 32 in the denominator. It had to go down to the bottom because of the negative. Okay? All right. I know that gets a little tricky. So now let's deal with fractions, or dividing, I should say. Okay, number 9. Let's do x to the negative 3 over x cubed times x squared, just a bunch of x's. Okay, so whenever we have these, it's kind of like when we were simplifying before with fractions. If you had multiple operations within the numerator or denominator, take care of those first. So I'm concentrating on the bottom. What can I do with x cubed times x squared? Combine, add them, right? I'm multiplying, so it becomes x to the 5. So this becomes x to the negative 3 over x to the fifth. Now, we got to do something else. What else can we do? We're not quite there. We could do that. You could bring it down. That's one way to do this. The other is to subtract the exponents. Either one. Do you want to just bring that negative 3 down? Make it x to the third in the denominator? Let's do that. Subtracting would have been another option, and both of them work. So now I have x to the 5 times x to the 3. They're both in the denominator now. Anything else I could simplify? Yeah. They have the same base. X to the 5 times x to the 3. So again, we add those exponents. 5 and 3 makes 8. Okay. The other option would have been to do negative 3 minus 5. We would have ended up with negative 3 minus 5, you're getting negative 8, right? We would have had x to the negative 8. Then you would have brought it down anyways. Either way, you get the same answer. It's whatever you're more comfortable with. Okay? You could have used the rule where it says subtract because they have the same base, and then bring it down, and then you get here, or bring it down first, multiply them, and it's there. Okay? Any questions? Yes. We're almost done here. Okay. Let's see here. I want you to try this one. It's the same idea. X to the negative 7 divided by x to the 6 times x to the negative 11. Okay? So you ready? All right. So obviously we need to take care of the denominator first. We have x to the 6, x to the negative 11. We have to add those. So what's that going to give us? Yeah. 6 plus negative 11 is x to the negative 5. And then x to the negative 7. Okay? So now, what do you want to do now? Again, we could subtract these or bring one to the bottom, one to the top. What shall we do? You want to subtract? Let's try it that way because we didn't do the subtraction method. If we, following the rule when we're dividing powers with the same base, we're supposed to subtract these. So look what this becomes, guys. Well, let's see. I don't want to lose anyone. Let me show you what the subtraction is. Negative 7 take away negative 5. This becomes x to the negative 7 minus negative 5. And then you could keep change opposite and you get negative 2. So now we're doing it a different way. It's by subtraction. Just to show you how that works. We could have done that in this one. So what's our final answer? 1 over x squared. Okay. And I should be boxing these. We're almost done. Okay. So this will be the last one, and this is going to have kind of like all the bells and whistles. Everything we possibly could throw at you is here. Number 11. Ready? So let's do 15 x to the negative 7 divided by 3 parentheses x to the negative 2 to the 4th. Lots going on here. Okay. So if I'm looking this over, I have coefficients that I could possibly divide, the 15 and the 3. I got a rule here for power of a power I got to use. I got negative exponents. What shall we do first? Parentheses, power of a power. I like that. Good thinking. So we got to multiply negative 2 and 4, right? That's what we have to do there. That's x to the negative 8. Okay. So now we got a few ways to do this. We have to reduce. We got the 15 thirds, right? We got to deal with that. What does that become? 5 over 1. So let's just write it as 5. And then do you want to use the subtraction method or flip them and do all that? Subtraction. Okay. So the subtraction method tells us that we have to subtract those. Okay. So that becomes x negative 7 take away negative 8. Yeah. You got to do keep, change, opposite. You could do that. And that becomes x to the 1. Or just x. So after all that, it just became 5x. Okay. Any questions? So really what we're doing is just combining all the rules that we've used before. I do recommend have some paper out, especially on the ones that kind of throw you a little. Take it step by step. Okay? All right. So the assignment is on delta, and there'll be questions just like this, ranging from kind of easy to these more difficult ones. Okay? All right, guys. Good luck.